So, today is part 2 of section 0.1, where we will be covering multiplication and division. Multiplication is the process of repeated addition. The result of evaluating multiplication is called the product. Another way to visualize the process of multiplication is as finding the area of a rectangle with sides of a given length. For example, if we want to do 3 times 4, we can take a rectangle of width 3 and length 4. Then, because each of these squares on the inside are unit squares, you just add them up, which there are 12, and that gives you what 3 times 4 is. This also agrees with the repeated addition way, because if I think of this as rows, you see that it's 4 plus 4 plus 4, which gives us the repeated addition. Now some multiplication facts. The number 1 is the multiplicative identity of the real numbers. That is, a times 1 equals a for any real number a. So just like with the additive identity, this is where you multiply by a number and that number stays the same, where the additive identity was 0, where you add it to any number and the number stays the same. Then every real number other than 0 has a multiplicative inverse, or more commonly known as the reciprocal. The product of any number and its inverse is 1. The reciprocal of a number a over b is the number b over a. That's why sometimes people say the reciprocal is the flip of the number. The concept of repeated multiplication is denoted by exponents. For example, a times a times a equals a to the 4th power. Notice for any real numbers a and b, a times 0 equals 0. Negative 1 times a equals negative a, or opposite of a if you remember. A times b equals b times a, and we say that multiplication is commutative. So just like addition, we get the commutativity property. Now when you multiply two numbers together, if they're both positive, so a positive times a positive, you end up with a positive answer. A negative times a negative, you also end up with a positive answer. And then the positive times a negative is when you will get a negative answer. And then since multiplication is commutative, if you did a negative times a positive, you also get a negative answer. Example 5. Complete the following number sentences if possible. So 3/5 times 1. Well, since 1 is the multiplicative identity, I know the number doesn't change, so we get 3/5. 5.78 times what equals 0? Well, 5.78 repeating, well, the only number that can result in a 0 product is if we multiply by 0. See, 1/3 times what equals 1? In other words, what is the reciprocal of 1/3? And that's where I said you think of it as the flip. So it's 3 over 1 or just 3. D is more of the same because it's saying 4 times what equals 1. So that's asking for the reciprocal of 4. Well, now how do I flip 4? Well, remember, any whole number can be thought of as a fraction if you think of it as 4 over 1. So then to flip that, we get 1/4. Now 0 times what equals 1? Well, since 0 times anything equals 0, there's no way to get 1. This one is not possible. Square root of 3 times 0. And even if you don't know what the square root of 3 is right now, anything times 0 is 0. Negative 17 times what equals 17? So this is what comes in handy, is knowing that 17 is the opposite of negative 17. And if you look up at the facts that we just said, to do that, you multiply by negative 1. Negative 17 times what equals negative 17? So what doesn't change? Well, that's the multiplicative identity, 1. And then 4/9 times what equals 1? Well, that's asking for what's the reciprocal again, so 9/4. So that's how you can use these basic multiplication facts to do some mental arithmetic. Notice, you can multiply anything by anything. 2.1, multiplying fractions. To multiply fractions, you just multiply across the numerators and denominators. Perform the following operations. Write your answers in simplest form. So you just multiply across, not cross, across. So 7 times 3 is 21. 13 times 10 is 130. Then if you can reduce it, you should reduce it. B, 8 over 15 times 10 over 8. Now when multiplying fractions, you can reduce any numerator with any denominator before performing the multiplication. Thus, here I hope you see that the 8 will cancel out with the 8, and then 10 and 15 are both divisible by 5. So the 10 becomes a 2, and the 15 becomes a 3. So now the problem becomes 1 times 2, and 3 times 1, so 2/3. I do want to redo this problem as if we did not know that to begin with, and show you do end up with the same answer, it just takes a little bit longer to get there. So for example, 8 times 10 is 80. 8 times 15 is 120. Well, both of these numbers end in a 0, so I can divide by 10 on the top and bottom to get 8 over 12. And then both of these numbers are divisible by 4, so I can divide by 4 on top and the bottom to get 2 over 3. So you do arrive to the same simplified answer. C, 7 over 4 times 5 over 3. Nothing here simplifies, so 7 times 5 is 35. 4 times 3 is 12. So we get 35/12. Notice, if you want to simplify the answer, you can do so before you multiply, as seen in Part B. Example 7. Perform the following operations. Write your answers in simplest forms. So we already did 8 over 15 times 10 over 8. Just to show you again, I can simplify the 8 and 8, divide the 10 by 5, divide the 15 by 5. 1 times 2 is 2, 3 times 1 is 3. For B, it's the 7s that simplify. 3 times 1 is 3. 1 times 5 is 5. We get 3/5. C, well, the 3 will simplify the 27 to a 9. Then 16 and 20 I can divide by 4 to get 5 and 4. So 1 times 5 is 5, and 4 times 9 is 36. So we get 5/36. And last but not least, D, 10/17 times 17/15. So the 17ths reduce to 1. The 10 and 15 can both be reduced by 5, and we get 2 times 1 is 2, and 1 times 3 is 3, and we get 2/3 again. Notice, avoid working with mixed numbers by converting all mixed numbers to fractions. As a refresher, to convert a mixed number to a fraction, you can use this little shortcut. You take the denominator times the whole number plus the numerator. So 4 times 2 is 8, plus 3 is 11. That becomes your new numerator, and your denominator stays the same. So 2 3/4 is 11/4. If we do the same thing with 6 1/2, 2 times 6 is 12, plus 1 is 13 over 2. Nothing reduces here. So 11 times 13, 143. 4 times 2, 8. Convert the onto part B, sorry. Convert these to fractions. 3 times 3 is 9, plus 2 is 11, over 3, times 2 times 2 is 4, plus 1 is 5, over 2. Nothing reduces, so we get 55/6. That's how you multiply with mixed numbers. 2.2, multiplying decimals. To multiply decimals, multiply the numbers as if they were whole numbers, then place the decimal point in your answer so that the number of digits to the right of the decimal point is equal to the total number of digits to the right of the decimal point in the numbers being multiplied. So what does that mean? So first off, I'm going to do 100 times 9,031. So that's 9,031 times 100. Now, I hope you remember that when multiplying by a power of 10, you just add that many zeros. So we get 903,100. Well, now I need to place a decimal number. Well, 100 had 0 decimal places to the right. 9.031 had 3 decimal places to the right. So 0 plus 3 means we need 3. So 1, 2, 3. So our answer is 903 and a tenth. B, 0.13 times 0.21. So again, I'm just going to think of this as 13 times 21. 1 times 3, 1 times 1, placeholder 0, 2 times 3, 2 times 1, add these together, get 3, 7, 2. Well, now I need to look at the original numbers being multiplied. 0.13 has 2 decimal places. 0.21 also has 2 decimal places. So if I add those together, my answer needs 4. So 1, 2, 3, 4. Oh, I need to add a 0 there. So we get 0.0273. 10,000 times 3. So again, I'm going to treat it like a whole number. So 10,000 times 3. Well, that's the same thing as 30,000. There's 0 decimal places here. There's 3 here. So I need 3 in my final answer. 1, 2, 3. Now looking at A and C, I'm hoping you're noticing the pattern that when you multiply by a power of 10, that's the same thing as moving the decimal to the right that many zeros. Okay. Now 2.1 times 3.02. So normally it would be 21 times 302. I like to put the more digits on top though, so I'm going to do 302 times 21. So 1 times 2, 1 times 0, 1 times 3, placeholder 0, 2 times 2, 2 times 0, 2 times 3. Add those together, 2, 4, 3, 6. Let me erase that. So we get 1 decimal place here, 2 here, so our answer needs 3. 1, 2, 3. So we get 6.342. Section 3, division. Division is the process of splitting a whole into equal parts. Also, division is simply the multiplication by the reciprocal. Perform the following operations. Now, A might not look like an operation because it's 4 over 1/2. But remember, this division bar means the operation division. So this is the same thing as 4 divided by 1/2. Now, from what we said, division is the same thing as multiplication by the reciprocal. So this would be 4 times 2 over 1, which is 8. So to remember going from here to here, you can use this mnemonic: keep, flip, change, or KFC. So you keep the first number the same, flip the second number, change division to multiplication, KFC. Now 27 divided by 3, because I'm not dealing with fractions, I'm not going to think of this as multiplying by the reciprocal. Instead, just 3 times what is 27? That is 9. C. 2/3 divided by 4/15. Oh, keep, flip, change, KFC. Now remember, when multiplying, you can reduce first. So I can reduce the 2 and 4 by 2, the 3 and the 15 by 5, and we get 5/2 as our final answer. Finally, D, 1/4 divided by 8/11. Well, keep, flip, change. So notice, originally it looked like the 4 and the 8 could be reduced, but after flipping, the 4 and 8 are both on the bottom. That means we cannot reduce them, because you can only reduce a top with a bottom. So 1 times 11 is 11, 4 times 8 is 32. Notice, don't mess with mixed numbers, just turn them into fractions, and you can always check division by multiplying. Perform the following operations if possible. So 0 divided by 3, what does that equal? Well, we can think of this as multiplication. So 0 divided by 3 equals what? That would mean 3 times what equals 0. And from our multiplication facts, we know that must equal 0. So 0 divided by 3 is 0. Now let's try to do the same thing with b. What's 0 divided by 0? Well, again, if we don't know what it is, I can use multiplication though. This means 0 times what equals 0. Well, this is a little funny because you can pick any number, and that's true. 0 times 1, 0. 0 times 13, 0. 0 times -7, 0. So because all real numbers satisfy this, we call this undefined because we can't come up with a specific answer. Now last but not least, 3 divided by 0. Again, let's say I don't know what that equals, but this would mean 0 times blank equals 3. Now this one is impossible because 0 times anything is 0. So there's no way to get 3. So because this is impossible, we say that this is undefined. And you can generalize these last 3 examples, as in 0 divided by any number will be 0, but a divided by 0 will be undefined, and 0 divided by 0 will be undefined. In other words, 0 can't be in the denominator. And that is it for section 0.1 notes.